Hello everyone, let's discuss complex integration. First, let's define integration along a real interval from a to b. Let a to b be a closed interval in R, and let h be a function from a to b to the real numbers which is piecewise continuous, i.e. h is continuous except at a finite number of points a0 to an. Then we define the integral from a to b of h of t dt as the sum from k equals 0 to n minus 1 of the integral from a sub k to a sub k plus 1 of h of t dt. Now let g be a function from the integral ab to the complex numbers be a piecewise continuous function. Then we define the complex integral from a to b of g of t dt as the integral from a to b of the real part of g of t dt plus I times the integral from a to b of the imaginary part of g of t dt. Now let's state some properties for this form of integration. First, there is linearity, that is, for f and g piecewise continuous functions on the integral ab and lambda and mu a complex number, then the integral from a to b of lambda times f plus mu times g of t dt is equal to lambda times the integral from a to b of f of t dt plus mu times the integral from a to b of g of t dt. We also have an additivity property, that is, for a function from the interval a to b to the complex numbers, and from a less than c less than b, we have that the integral from a to b of f of t dt is equal to the integral from a to c of f of t dt plus the integral from c to b of f of t dt, and the integral from a to b of f of t is equal to minus the integral from b to a of f of t dt. We also have a substitution property, that is, if phi is a function from a to b to c to d and is differentiable, and f is a function from c to d to the complex numbers, then the integral from c to d of f of s ds is equal to the integral from a to b of f of phi of t times phi dash of t dt. Further, we also have an estimation property which says that if f is a function from a to b to the complex numbers, then the modulus of the integral from a to b of f of t dt is less than or equal to the integral from a to b of the modulus of f of t dt. And as ever, thank you for watching.